All right, some technical difficulties this morning, but hey there, and welcome to Into the Terminal, episode 13. Today we're going to be discussing firewalls. I'm Eric, the IT guy Hendricks, and joining me every single episode is my trusty co-host Scott McBrien.
Good morning, Eric.
Morning. Let's see. Joys of live streaming here. Boost your gain here. There we go. All right. So Scott, while I get a couple of things fixed up, you wanna give us a quick introduction as to what a firewall is and what it does? Just a second.
Sure. So a firewall is going to be a layer that's included with the kernel that controls access via the networking stack to pass traffic to services running on your system. So as connections come into your IP address and they're addressed to a specific port, the kernel's job is to take care of that incoming connection and pass it off to the service behind the scenes that actually serves it. So we took a look at service management a few episodes ago. But basically, like because the kernel has to handle every incoming packet, that makes it a great place to actually stop, look at the packet, and decide whether we really want to pass it to that backend service or not, or put any limitations on who can utilize those services. So on Red Hat Enterprise Linux, we use a command called firewall-cmd, firewall command, and we could do things like firewall cmd list services. And these show us the services that are currently allowed to pass through our firewall. And we'll get a little bit more deeper into this after the transition. Um, but this will like be good enough to start off with. We can also take a look at what one of these services is. So for example, I can do a firewall CMD info service on SSH. And it tells me things like the port or the protocol or any other additional parameters that ties the word SSH to what it really does in the firewall. So we try to use our services as kind of like a standard list of ports so that adding them or removing them from the firewall configuration to either permit or refuse traffic is very straightforward and simple. All right, so on this machine, I've also added a web server. So I want to add a service for the web server as well. So dash dash add service. And now when I list the services, we can see that it's listed there. But if we take a look at the info service for HTTP, notice that it's only port 80. So if we also want to do secure socket layer web traffic, we'd have to add an additional service, HTTPS. Again, HTTPS. So that adds port 443 to our list. And now when we do a list of services, right, we see both listed in there as allowed through the firewall. All right, the other thing that we do with firewall stuff is it can be really dangerous, especially when operating on a remote machine like what I'm doing. So any changes that are made are persisted in memory only. So like if I jack the machine up really badly by blocking all traffic or something that removed my access to it, we could do something like reboot the machine and all of the changes that I have made thus far persist only in memory. So a reboot would cause them to no longer be there. So that's kind of a safety mechanism that we can use to get things set the way we want. And then we need to persist those changes to be permanent. So the services I added were HTTPS and HTTP. And we're going to add on an additional flag, permanent. And now those two services being added to the firewall configuration will persist between reboots. Right. So the easiest way to do that is just recall your command history for the commands that you've done on the firewall and just add dash dash permanent to the end, and that'll go ahead and persist them once you're happy with your settings. All right, the last thing is what if we no longer want to do something? So, for example, maybe I no longer want to do HTTP services. I only want to do secure socket layer. So if I added it like this, Eric, I'm guessing you can probably guess what the option is to get rid of it.
Well, I'm assuming since it's an add, we could do a remove.
Indeed. And again, this was, whoops, move. Okay, let's see what we got here. The services. Okay, so a little bit too fast on the up arrow. And then if I wanted to make this a permanent change, of course, I'd have to remove service dash dash permanent so that when I reboot the machine, it would no longer show up as well. So now it will be added back in. All right. Want to transition to the second part of the show, Eric?
Sure. So with the firewall commands that we just started going through, we were interacting with what is known as the default zone. Zones within firewalls can apply to different network cards, can apply to different IP ranges. So you could have an internal network or an external network. So if we do, let's see, pull up my notes here. Sorry about that. Some problems with the stream. So Firewall CMD, we can get active zones, and that will tell us what zones are actually configured on the system. A lot of times you'll see kind of a local subnet. You'll see a maybe an internal network. So within your data center, and then you might see public internet. So you can have different ports available in different zones. So right now we've got one network card connected, and that's our ETH0 interface. And you notice that's part of a trusted zone. So that's what comes pre-configured with our firewall here on RHEL 8.5. And so we can actually see what the default zone is. So if we've got multiple defined, we can actually get the default zone by go figure, get default zone. So you notice that it's trusted. So any changes we make, like at the top of the show when we were talking about the web server, any changes that we make will automatically get applied to the trusted zone unless we otherwise specify within our command.
And Eric, I'm going to go off script for a second here.
Go for it.
I wonder. Zones. So these are all of the defined zones on the system. And the idea behind a zone is that it allows us to group rules for a specific set of people. And it also allows us to assign interfaces to a specific thing. So if you're working in a multi-homed or multi-network card environment, where maybe one card is connected to your internal network and one card is connected to your external network, you could do something like put your internal network card in either the internal zone or the trusted zone like we've got here. And you can put that external card in the public zone, and then you could choose what services or what traffic is allowed through each of these different zones. So a zone is really just a method of grouping rules together to apply to a specific situation.
Let's see. Kind of off my game this morning. That streaming issue kind of threw me off. So thank you for jumping in there. I feel pity on the dark mode folks that it's just a single point of failure. I mean that's why we double up in the morning, because teamwork. So let's see. So we've got let's do an info zone on probably the trusted zone, since we've been working with that one. That allows us to kind of zoom in And so you notice, as Scott was showing at the beginning of the episode, that we've got our cockpit, our web console, we've got HTTPS, so we're only allowing secure web traffic to come in. We've got SSH, which allows us to connect in, uh, remotely to the terminal, and then we can add custom ports. We can do some port forwarding. There's a few other options within the firewall that this allows us to get visibility into. So far, we've only made changes to services that have a single port. But Scott, what if we wanted to add a service that has multiple ports involved?
Sure. And that's actually one of the nice things about the idea of a service when it comes to Firewall D on Red Hat Enterprise Linux. So, in the olden days, we maintained our firewall settings and we would have to manually put in rules for every single port that we wanted to allow or refuse or whatever the case may be. But with Firewall Command and Firewall D, we can group those things together into these services. And so let's pull up a info service for one of these multi-port services.
One service that comes to mind is Samba. There's some times early on when I had to add some printers to a server that would pull information from a database and massage that data and then output the results to a printer. So we had to add those particular Linux servers to a Windows network to get access to the printers. So the Samba service allows us to integrate with Windows networks. That I get that that's overly simplified, but the Samba service is great for interacting with Active Directory, Windows domains, and otherwise. But we've actually got a couple of things to point out. You notice that there's 4 ports that are tied into the Samba service: 137, 138, 139, and then 445. But we can also drill down into our security a little bit more by specifying either UDP or TCP, or both. Sorry, do you want to
Yeah, that's a
expand on that a
function
little
of
bit?
like, yeah, that's a function of how the service communicates. So UDP is what they call a datagram protocol. So essentially, it sends a packet, and then there's no tracking on whether that packet actually ended up at its destination or not. But because we just like send out the packet and then don't keep track of it anymore, there's less overhead on that traffic. TCP, on the other hand, does the TCP handshake, where the two machines kind of open a connection between each other. And then as traffic is sent between the two machines, they send check boxes back and forth to each other, or packets, to see how much has been sent and how much has been received. And if there's any missing traffic, the sender can resend it so that the recipient gets all of it. So when you're dealing with port-based rules for firewall, you need to know whether you're talking about UDP-based ports or TCP-based ports. And with a service like Samba that's a little bit more complex, some of the port traffic is UDP-based traffic, and other port traffic is TCP-based traffic. So that's a nice thing about services here, is we can kind of group it all together as a single unit. So if I want to allow Samba traffic to get through my firewall, right? I just add the service, and that adds rules so that port 137 UDP, port 138 UDP, port 139 TCP, and port 445 TCP are now just permitted, right? I don't have to write 4 different rules, and I don't have to figure out which protocol is needed for them, right? Red Hat has packaged this all up together into a service definition, and I can just deal with the service definition.
So that brings up a good point, Scott. What if I've written some homebrew application, something that is specific only to my environment? Is there a way that I could perhaps add in open up ports in my firewall that aren't part of an official service?
Yeah, absolutely. So, in a previous episode, we were talking about SSH, and one of the things we had mentioned was changing the SSH port to a different port. And so, if we were to do that, we couldn't use the standard service for SSH because That's port 22, and we just talked about changing it to a different port. So there's a couple of things that we could do. One is we could adjust the service definition on my machine to talk about the new port, and then we could still do our service level add and remove to work with it. The other alternative is we can just deal with port-based settings in Firewall D. So I could do a firewall cd -add port equal. Maybe we set it to port 2022 instead of 22. And then we also need to know the protocol that's used. So SSH uses TCP-based connections. Right? And now if we do that info zone on trusted, right, we could see that my individual port that was added is down here listed in the ports that are permitted through this zone.
So if I wanted to troubleshoot from one system to another, there's a number of different utilities, and we wanted to highlight one of them specifically, two ports. So if we've got a destination server that we've changed the SSH port from 22 to 2022, like we have here, if I'm sitting on my local machine and I'm trying to get to that remote machine, I can actually use a package called nmap to basically pull a destination host and see what ports are available. So if I were trying to connect from this box to another box, I could actually do an nmap and then the IP address, and that command will actually return back a list of ports. It'll essentially do a quick port scan that will tell me what ports are listening.
Yeah, and before we do this, I feel compelled to point out that nmap works by sending a storm of traffic to your destination, right? So I'm doing an nmap against my public IP, and really what it's going to do is it's trying to connect to every single port on that IP, which, depending on the area in which you work, may cause interesting side effects. So if you work at a place where your network team does a lot of traffic monitoring and traffic shaping, they will likely notice that you have run this, and it will set off all kinds of flags in their network operations center because there's this like huge volume of traffic that goes to every port on a host, which is a hallmark for something like someone trying to do a scan or an attack on a host. So depending on where you work or depending on what machines you're using, first, you want to make sure that it is permissible for you to use a tool like nmap, because you don't want to be on the end of the phone call when the infosec team or the networking team finds out that you were that person. They call you up and chew you out for doing something you shouldn't have. But here in our little lab environment, it's fine. I give us authority to scan hosts, so we're going to go ahead and run it.
Yeah, and just the speed at which that command comes back. I mean, just think about the thousands of ports that are there, and how quickly the command returned to us with the results. Just how quickly you're just slamming your target node. So
Yeah,
we noticed that we've got the Zeus admin, HTTPS, HTTP, and SSH all open.
So interestingly, that Zeus admin port, that port number looks oddly familiar.
It does. It does. Can I have web console for 200, please, Scott?
Exactly. So this is the port that the cockpit service is listening on. But notice that it's called Zeus admin. And so, Eric, I'm going to put you on the spot, but it's okay to not know the answer to this question. Why is it showing me Zeus admin? Why isn't it showing me something like cockpit?
That's a great question. I'm not sure what Zeus admin is, but I can say that when these particular service profiles were written, that Zeus admin was kind of the official application that was written to use 9090. There's a bunch of standards, say like 22 for SSH or 25 for mail communications. and 80 for unsecured web traffic. So whenever this particular service profile was written, Zeus admin kind of had I actually can liken it to calling dibs. It doesn't really mean anything, but that's just kind of the designation.
And I'll do you one better. You know how we have things like Etsy hosts, which is a static definition of host names and IP address mappings? Well, it turns out we have something similar for services. So there's a file called, oops, helps form the right window. There's a file called Etsy services. And basically it says, here's the port number and here's the name that goes with the port. And so if we look for port 9090, WebSM, and is there another one? That's disappointing. I'm completely incorrect. I would have expected this guy to show up in that nmap output instead of Zeus admin. So it must be pulling that data from somewhere else. But this is why typically you'll see something like SSH is port 22, and you go back in. Right. So that's why that token is listed there next to the port.
And actually doing a quick Google search in the background, Zeus looks to be a deprecated web server that used to be in Unix and Unix-like platforms. So interesting.
Yeah, and so when you get those like weird ports that have weird names, I wouldn't put too much stock in the name, because really what's happened is it's seen that the port number is open, and then it goes to reference some file to figure out what human name to assign to it under service, which may or may not be accurate for what you're doing, right? So like, let's see if port 2022 is in there. Yeah. So I would expect if we actually were listening for SSH on port 2022, that it would show as the service either down or Xinu expansion 2 as the service that's running on port 2022, because nmap doesn't know the actual daemons that are connected to those ports. It's just able to connect to the port and see that it's able to make a connection, and then report back based off of this file.
So I wonder if we changed port 9090 in that Etsy services file, if it would then reflect, except it's pulling from somewhere else, so it may not reflect.
I wonder if that's maybe in the nmap settings. It's something
that could be
down offline.
Yeah. Anyway, that's the fun of being a systems administrator. It's such a broad topic that even after 10 or 20 years of doing it, you still find interesting things. So that might actually be part of nmap instead of the firewall or Etsy services. If anyone knows or finds out, please add that to the comments. We'd love to hear from you and be kind of a scavenger hunt for today. So before we wrap today, we wanted to talk about we've used the firewall CMD command almost exclusively today. And those of you that have worked with RHEL 6 or RHEL 7 or maybe other distributions, the default is actually iptables for a lot of the work that we did. However, with RHEL 8 and beyond, that's changed a little bit. And instead, we're using nftables now. Scott, do you want to kind of address what the change was?
Sure. So with Red Hat Enterprise Linux 8, we added an alternate firewall port filtering technology into the distribution called nftables. And let me just see if it's loaded here. Oh, crap.
No.
Yeah. So we can see that on this machine, nftables is the module that's been loaded in the kernel that does that packet inspection for the firewall. We also, for Red Hat Enterprise Linux 8, ship iptables. And as Eric mentioned, in the olden days, you'd use the iptables command line command and write rules for your firewall. And you could still do that today with nftables. However, things like adding and removing services with the firewall CMD command, like that's really convenient and helpful. Organization of zones, to help make managing connections a little bit easier. Those things are not in nftables or iptables, right? There's an abstraction layer that sits on top of that that handles that called Firewall D. And the Firewall CMD command interacts with Firewall D. Firewall D then interacts with the port filter running behind the scenes. So on our system, it's nftables. As I mentioned, RHEL 8 also ships iptables. So you could swap the two out. And it turns out Firewall CMD would work just the same with iptables behind the scenes doing the stateful packet inspection. So if you've kind of adopted this Firewall D, firewall command methodology of working with your firewall rules, the backend technology change of iptables to nftables completely invisible to you. And that's important because in Red Hat Enterprise Linux 9, there is not iptables. So if you are using iptables directly on older systems like RHEL 6 or RHEL 7, that's not going to be available to you on RHEL 9. It will still be there on RHEL 8, but in RHEL 8 it was marked as deprecated, and in RHEL 9 it's not shipped. So you'll want to get familiar with Firewall D and Firewall-CMD as your interface.
Is having gone from iptables to nftables, and especially with the addition of the firewall CMD command, if you are newer to Linux or to being a systems administrator, I can definitely vouch for the improved simplicity of using firewall CMD. Because the Iron sysadmin put a sample iptables command earlier in the chat, and to me this reads so much harder than just the firewall the firewall CMD commands that we've been using today. So it is much improved. There's a lot more organization around it, but just know that that change is coming. So if you have RHEL 7 boxes and RHEL 8 or RHEL 9 boxes sitting in the same environment, just know that kind of the back end of that will be a little bit different.
Yeah, and one last thing on that, like while working with iptables or nftables directly can be very complex and they're extremely syntax rigid, they also offer a ton of customization and flexibility, right? Because there's so many things you can mess around with on what package you're looking for. Well, it turns out that Firewall Command and Firewall D have the same thing. We call them rich rules. So if you are using things that are highly customized packet inspection or packet filters, you can use them in Firewall D as a rich rule, and it'll put it into nftables or iptables with the right syntax.
And then Shane also asks if this change applies to Red Hat only. I'm pretty sure that CentOS Stream and Fedora have both implemented this change ahead of RHEL, but I also suspect, now this is just what I expect, because Firewall D, iptables, all those are upstream packages that are built into RHEL, that this was a change made at the upstream level as opposed to at the Red Hat Enterprise Linux level. So a lot of the changes that you see will filter down from upstream, whether that's Fedora. For RHEL, you can usually look at the latest version of Fedora and see what Red Hat Enterprise Linux is going to look like on down the line.
So I read that question a little bit differently. I thought he was asking about other Linux distros outside of the Red Hat family.
Oh.
And because this is a change to stuff that's distributed with the kernel, right? iptables was a kernel module. nftables is a kernel module. I have a feeling this is in other distros as well.
Right. And I think we answered it the same way, just from different directions. You use fewer words. and a shameless self plug. If you're interested in the Fedora CentOS Stream RHEL story, we are going to do an episode of RHEL Presents later on today at 1 p.m. Central, 2 p.m. Eastern, where we will be interviewing the Fedora project lead, Matthew Miller, for the Fedora community. So if you have time this afternoon, I'd highly recommend you come back to our channel here on YouTube and join Brian Smith and myself for that interview. I'm really excited. I'm a passionate Fedora user. My workstation right down here next to my desk is running Fedora 35, and I am really excited for Fedora 36. So if you're curious about the relationship between Fedora and RHEL, join us for that. Also, join us tonight for Dark Mode, where Scott will see if he can break the firewall and bork his demo right in the middle of live streaming. And then tomorrow, Scott, I think we're covering SE Linux.
I think you're right. So a little bit of introduction to SE Linux so that we can get you past I just disable it and make Dan Walsh cry. And then
we may have to explain the origin of that joke tomorrow.
Don't forget that if you enjoy this content, you want us to make more like it, bang that like button. And if you think somebody else would enjoy this as well, share it with them. And if you're interested in other things, like I'm going to be tuning in for Eric's show this afternoon with Matthew Miller as well, you can subscribe to the Red Hat Enterprise Linux channel and you'll get notifications and alerts that we're going to do those things.
Definitely. Well, thank you all so much for bearing with us today as we overcame some technical issues. Scott, thank you so much for driving while we fix some things on the back end. But anyway, see you for RHEL Presents. Scott will see you guys tonight for Dark Mode. And until then, have a great day.